Anyway, moving on from that question, we'll go on to this one here. This one isn't actually a bad question. Start off with the proof that root 2 is not a rational number. Again, it didn't come up last year, so could be a good idea to know this one off because it's pretty easy. It's kind of 3 marks. Okay, so I'll do the whole proof and you can just learn off what I write if you want. We're going to assume root 2 is rational. I haven't done this proof in a while, but it's not hard. Assume root 2 is rational. That means that the square root of 2, a over b, where a and b are integers. You don't have to write kind of like this as well. God, I haven't written the integer sign in a while. So a and b are integers, that just means they're whole numbers. So a and b are integers. B is non-zero. And we can also assume that the highest common factor, this is the proof basically, the highest common factor of AB is 1, or yeah, they have no highest. Basically, the fractions in its kind of simplest form just means A and B have no kind of factor, I guess. That's actually what we end up doing, but this is usually the first step. We assume it's rational. Rational means it can be written as a fraction. So 5 over 3 fractions, 4 over 10, just fractions. A over B, this is just how you do it. You say root 2 is equal to A over B. Now, what we're going to do is we're going to square both sides. So square root of 2 times the square root of 2 is just 2. A squared over B squared, or A over B squared is just A squared over B squared. Now, we can say that multiply across by the B squared, 2B squared is equal to A squared. Okay, so what this means is A and B are integers, so we can say from this, thus, A squared is like A squared is an even number, or is, when we say a multiple of 2, yeah, we'll say a multiple of 2. So A squared is a multiple of 2. A squared is a multiple of 2. And then there's like some theorem that says basically if A squared is a multiple of 2, so is A. You don't have to know how to prove that for the Leibniz there, but we can just say A squared is a multiple of 2, and we can say, and so A is a multiple of 2. What that means is that A is divisible by 2. So what we can say then, we can say that implies that A is equal to 2 times K, where K is some integer. Okay? Now, why is that important? Because that means we can say that 2B squared is equal to 2K squared. So what I've done there is I've taken A and just subbed in 2K, because I've said A is 2K. Okay, and so multiply this out. I get 2B squared is equal to 2K squared. Be careful with this, it's actually 4K squared. A lot of times people forget about the 4. Now what we do is we divide both sides by 2, and we get B squared is equal to 2K squared. And what we do is we use the same argument as we did with A. We can say, so B squared is a multiple of 2. Multiple of 2. So, maybe I'll say thus. Sound a bit better. Thus, B is a multiple of 2. The reason this is important is I've said B is a multiple of 2 and A is a multiple of 2. But then, so this is what we've, but then A and B have a common factor common factor of 2. Common factor of 2, which means they're both divisible by 2. So since they have a common, basically what I said originally is that the highest common factor is 1, and I've just shown that if I assume it's a rational number, I assume it's equal to a over b, I can show that this leads to the fact that they must have a common factor of 2. So this is kind of like saying, I think last week we did some sort of simultaneous equations, and I think we got like 1 equals 0 at the end, which basically means for something to be true, 1 must equal 0. So what you do here is you just show that if you assume it is rational, it's called by proof by contradiction. You assume something is true, then you show that that must lead to like a very obvious contradiction. So at the start we said that they have no highest common factor, or that the highest common factor is 1, and I've just showed that if it's a rational number, they must have a common factor of 2, which is a contradiction. So all you have to say is have a common factor of 2, which is a contradiction. Which is a contradiction. Full stop. And then I guess we can do our little therefore. Root 2 is irrational. It means it can't be written as a fraction. Okay, that's all you have to do. If you just want to learn this off, literally maybe just take it over in your head and learn it off. Could come up, and it's a free 15 marks if it does. Now, these were the log ones. This was a harder log question. I only noticed recently as well, for any time they're given log questions, for the leaving cert, I think we did one last week as well, this formula always seems to come up. This formula is probably one of the most useless formulas ever. Like, you literally never use this formula, but I think they just like giving it on the leaving cert just to be a bit tricky, so a bit unfortunate. But anyway, t is a positive real number with, okay, we're given this kind of equation here, and then it says find the value of t and give your answer in this form here. So 3 to the r, where r is q is a rational number. So the last one we said we proved root 2 was a rational, just a fraction. So it just means it's a fraction. Okay, we're gonna have to use this formula, obviously. At least they give us the hint for that. What ones we're gonna leave this one, and we're gonna change these ones. This formula just lets us change the base. We're gonna change the base, all of them, to 3. So I'll just do the first one. So let's say we have log 9t. So looking at this formula here, you can say a is 9, b is t, c is our the new one we want, and we want to turn it to 3. That's just because we want all of them to have the power, the kind of 3. And you can see these are all powers of 3, 9, 27, and 81. Hard to see this, but sometimes if you just do it, you'll see. A lot of times they give you one like this, just reduce it to the most obvious one. So now I'm just going to substitute this into my formula. So this becomes log, look where c, so c I said is 3. So log base 3 of b, which is t, divided by log, again, c, 3, 9. Okay, now, again, if you don't know this, put this into your calculator. But this is the same as log 3t. Log 3 of 9 is 2, so over 2. Similarly, if you do this one here will be log 3t over 3. And this one here will be log 3t over 4. If you do them all one by one, you'll see. So what that means is I can rewrite the top thing as log 3t. So I'll probably write my t's a little bit differently. Log 3t plus log 3t over 2 plus log 3t over 3 plus log 3t over 4. And that's equal to 10. So what I'll do is I'm going to factor out the log 3t. I'm going to get 1 plus a half plus a third plus a quarter. Oh, I should have had a calculator on me, but what you do is, sorry, let me equal that to 10 as well. I'm just going to do this on a calculator quickly. So 1 plus a half. I actually don't have a calculator on me, but let's see, plus a third, plus a quarter. Jesus, what the hell is that? It's going to be something over 12 anyway, isn't it? 7 over 12 maybe? No, 18 over 12. Okay, it's 25 over 12. So what we get is that log 3 of t. Actually, and then it's that number in front I should probably write. So basically I end up getting that 25 over 12 log 3 of t is equal to 10. Now, I can rewrite that as log 3 of t is equal to 120 over 25. And I can simplify that a bit. Really, I should have a calculator on me right now, but I can divide 5 in on both sides. So if I divide 5, I get 5 on the bottom, and then on the top I get again 120 over 5. 120 over 5. 24, sorry, so 24 over 5. So what I get is log 3t is equal to 24 over 5. Now, I don't have my tables book on me, but remember our formula we're looking for t. We have our formula a to the x is equal to y if and only if log base a of y equals x, I think. I think that's how it's written in the tables book. So look at our formula here. I can say a is 3, a is 3, y is t, and x is 24 over 5. So now I can rewrite this in this form here. So I can say t is equal, that's y, a, which is 3 to the 24 over 5. Okay, and that's our answer because that's how we wanted it. So 3 to the 24 over 5, and we can't simplify that any further. Okay, that's not an easy one now. These ones aren't too bad now. It says explain what log base 6 of m means. M is a positive real number, that means none. What this means is 6, or it just means kind of to what power do we have to raise 6 to get m. So what that means is 6 to the x is equal to m. Okay? For what x? For what x basically? For what value of x? Well, I wouldn't really write that. To what power do we have to raise 6 to get m? Then we're told m is a real number and m is greater than 6. If m is greater than 6, so think log 6 of 6 is 1. So that means to what power does 6 have to be raised to get 1? And 6 to the 1 is 6. So if it's bigger than that, it basically just means, if it's bigger than 6, it just means that if it's bigger than 6, it just means that log base 6 of m is bigger than 1. And that's all we have to do. Again, this was a hard question, I'll be honest. It came with the first nice part, but the rest of it was kind of nasty.